Welcome to my class. Today I am going to discuss numerical problem based on nodal analysis. You can read the problem statement. Find the current flowing through 1 ohm resistor using nodal analysis. That means this is your circuit given to you and you have to calculate the current flowing through 1 ohm resistor by nodal analysis. So these are the steps one can follow to solve this numerical problem. Now solution approach. First of all, we need to find the principal nodes. So here point A, B, C are your principal nodes and the red colored line is your reference node. And we know that reference node potential is equal to 0. And we have to calculate the current flowing through 1 ohm resistor. Now we need to assign some voltage variable for each principal node, but here we can see this voltage 4 volts is directly connected to the node A. That means the potential at node A will be your 4 volt. Here I have written voltage at node A is equal to 4 volt. Why? Because here you can see that I have written clearly that node voltage at A is directly equal to 4 volt because the 4 volt source is directly connected to the node A without having any series resistance. That means here there is no series resistance. So in this part there is no voltage drop. So here in this part there is no voltage drop anywhere. So total voltage will appear at node A. That's why no need to define any unknown variable for node A, because we already calculated the potential at node A, that is VA is equal to 4 volt by carefully watching the circuit. So no need to assign any unknown voltage variable for node A. Now at point C, 1 ampere and 3 ampere currents are incoming current and I have assumed I3 current as a outgoing current from point C. So if I apply KCL at point C, so KCL will give us I3 value as 4 ampere. So if you see the notes, I have written clearly that we can also see that at node C, two currents 1 ampere and 3 ampere entering the node C. Now the KCL equation at node C will give us the current flowing through BC branch. So this is BC branch and we can easily calculate the value of this BC branch current by applying KCL at node C. So no need to assign unknown voltage variable for node C, as we can calculate the branch BC current by applying KCL at node C. So only variable we need to assign for the node B to calculate our solution for this problem. That means we have to assign only one voltage variable for node B here to calculate this solution. Now at point B, if we apply KCL equation by considering the current I1 which is coming from A and entering to node B, I3 already assumed, and I2 current I have assumed which is coming from node B and entering to node B. So if I apply KCL here, so KCL will give us the equation I1 plus I3 is equal to I2. I have written here in equation number 1. Now apply Ohm's law. So I have to replace this current equation in terms of voltage equation. So for this I1, I have written this potential minus this potential divided by path resistance 2, because the current is flowing from A to B. So potential A is higher as compared to potential B. So that's why I have written 4 minus VB by 2 is your current equation I1. And I3 already calculated earlier, and it is 4 ampere. And now I2 is equal to potential difference between these two, that is VB minus 0 by path resistance 1 ohms. So I have written VB minus 0 by path resistance 1 ohms. So if you simplify, you will get the potential at point B is equal to 4 volt. Therefore, current flowing through 1 ohm resistor is, you have to replace the potential value VB at current equation I2. That means if we replace VB by 4, so we will get 4 by 1, it is equal to 4 ampere. So this is the solution for this numerical problem. Thank you very much.